Keep heading, everybody. Discovery of neutrons. So till now we have studied in the last previous classes. We have studied two subatomic particles. So that is one is discovered by Mr. J.J. Thomson. Another one is discovered by whom, guys? Everyone? One is discovered by Mr. J.J. Thomson, and another one is discovered by whom? Protons. Protons is discovered by whom, guys? Eugen Goldstein. Rutherford not found. He studied the only properties of atom. You understand, Mr. Nivedan? Yes, please. Yeah. So that is what. So today's class we are going to see the discovery of neutrons. So please remember that. So after the discovery of subatomic particles, that is what electrons and as well as protons by Mr. Goldstein, it was assumed in the year of 1920. So there are only electrons and protons is present in the atom. So up to 1920, 1932 also. So people used to consider that only number in any atom, only the two subatomic particles are present. That is what is electrons and protons. But in the year of 1932, so a scientist name call it as James Chadwick. So keep reading, everybody. So discovery of neutrons. Mari, am I audible? Discovery of neutrons.
Sure.
So after the year of 1932, so what is the importance of years? So those who came to Sekri, they knows. Do you all remember everybody Sekri competition? When the teachers, there is a competition for teachers. Importance of years and scientist photos and all of you. I think that day you may remember that. Am I right, guys? So every scientist and every photo is every year is important only. So definitely in competitive exams they will ask. So remember that and wait. So in 1932, Mr. James Chadwick, an English scientist, discovered the another subatomic particle. So what's his name, everyone? James Chadwick. So he discovered the another subatomic particle. That is what we used to call it as neutron. Sir, why sir neutron is not discovered earlier? So that is also we are going to make it. So from the time of J.J. Thomson to the Chadwick, so many years passed, but still there is no discovery of neutron. So here, Mr. Chadwick, what he has done, what makes him to discover the neutron? Everybody knows the Chadwick has identified how it is. So how he has been noticed that he is trying to bombard at the beryllium foil with the alpha particles. Do you understand? See, Mr. Rutherford bombarded the gold foil with alpha particle. Am I right or wrong, everybody? Yes or no, guys? What is the foil he has been taken? Gold only. Is it right, guys? Please respond. So, Mr. Rutherford has been passing the alpha particles through the gold foil. But now, Mr. Chadwick, he bombarded means collision. So, he bombarded the beryllium foil with alpha particles. If you are active in the class will be good and you have to respond, it will be fine. If not, I'm not interested to take. So with alpha particles, and observe that a chargeless particles having 1 AMU mass coming out. So notice that when bombarded the beryllium foil with alpha particles, he noticed that what he observed that he observed the chargeless. So that is the reason we say neutrons. What is the charge of neutron? Anybody can tell? What is the charge of neutron, guys? What is the charge of neutron? Is there anybody in meeting? So if not interested, we'll stop the class. What is the charge of neutron? You all don't know. Electrons, positive, negative charge. Protons, positive charge. What is the charge of neutrons?
Neutrally charged.
No charge. That is what neutrally. They are not neither positive nor negative. They are. That is what. So particles having 1 AMU mass. Having 1 AMU mass is coming out. Is coming out. So later on, he confirmed that these chargeless particles only, whatever they are coming out, the chargeless particles only, we used to call it as a what? Everybody. We used to call it as, yes, please, neutrons. So when he bombarded this beryllium with, note it everybody, beryllium symbol is Be, Bryllym. Beryllium symbol is Be. Atomic number. What is the symbol for atomic number? Again, today we are going to study, and already I have taught you. What is the symbol for atomic number? Symbol for atomic number
Is it?
is Z. And what is the atomic mass number? This is atomic number. Please remember that. Atomic number and atomic mass symbol. I want it. Atomic mass.
A.
A. So note it everybody. The beryllium atomic number is 4. Atomic mass is 9. When it is bombarded with the helium alpha particles means what? We are already familiar. What do you mean by alpha particles? Helium only. Is it right,
Helium.
guys? Yes. So He2 plus, that is what? What is the atomic mass of helium 2 plus? Everybody? What is the atomic
4.
mass of helium 2 plus? 4 units. That is what? So 2 and as well as 4 alpha particle. So please remember alpha particle. So he has noticed that we are going to get a substance, call it as carbon. Carbon is forming. Okay, so carbon means 6. So 4 plus 2, 6. And here electrons, 9 plus 4. Basically, we are getting here only 12. So one neutron will be there. So mass of neutron. So that is what, and he noticed that neutrons are coming without any charge. Without any charge. That is what, having a mass of, what is the mass of one neutron? Everybody? Mass of one neutron, how much it is? 1 AMU. What is the mass of one neutron? 1 AMU. Do you understand, Amma? So from that only we'll consider approximately mass of proton and equals to mass of neutron. Mass of neutron and mass of proton is approximately equal. That is why atomic mass means we will consider number of protons plus number of neutrons. That is what together we used to call it as mass of atomic mass of an atom. Is it okay, everyone? Please respond. Understood or not? Everybody? Yes.
Yes, sir.
Yeah. So that is what I want to say. So this is what is about it. Anyone having doubt, you can ask me. So finish it fast till here. Clear, guys?
Yes, sir.
Yes. So neutrons has been found. Neutrons are the neutral particles present in an atom, and they do not possess what? Anybody can tell? Do not possess
Any charge.
any charge. So what is the charge of the neutrons? No charge. So that is what, and he represented, neutrons is represented by, what is the letter representing the neutrons? Not capital letter. Represented by, what is the letter? Small n. That is what you have to remember. Now again I'm saying number of moles. Number of moles also small n. Neutrons also will represent with a small n. Number of particles. Number of particles will represent with a capital N. Avogadro number. Avogadro number, what is the symbol? Everybody's? Avogadro's number, N naught. So don't get confused with the symbols. Number of moles also N. Neutrons also N, only the symbol. Okay, everybody? So that is what. So if I take, so what is this? So let us take the example of carbon. So what is the atomic mass of carbon? Anybody can tell? What is the atomic mass of carbon? I am asking. We already studied from the last chapter. Atomic mass of carbon. Atomic mass of carbon. What is 1 AMU? At least define that. What is 1 AMU from the last chapter? Otherwise, I will stop the class. What is one AMU? Define the class. Anybody? What is one AMU?
1 by
Yes.
1 by 12th of the carbon
1/12th of the carbon 12 atom. Am I right, everyone? 1/12th of the carbon 12 atom is only 1 AMU. Is it right or wrong? Means a carbon atom, if you have been taken, you need to make it into how many equal parts? How many equal parts? 12 equal parts. 12 parts if you have been made, then mass of one part is equals to 1 AMU. So that is what we have been taken. Am I right, everybody? So what is the carbon atomic mass, I am asking? So that is only we have studied. Carbon 12. 12. Carbon 12. 12 indicates what? Atomic mass of carbon. So atomic mass of carbon is 12. What is the atomic mass of carbon, everybody? Atomic mass of carbon is how much, guys? 12 AMU. This is what is that. Now, what is the atomic number? Anybody can tell? What is the atomic number? Atomic number of carbon.
6.
What is the atomic number of carbon? 6. So, if you have noticed it here, we all know electron mass is neglected. Electron mass is neglected. Then how the 12 it will come? 12 AMU. So that is what. So please remember the point. In any atom, write it. In any atom, any atom, number of protons is always equal to number of electrons. But number of neutrons may or may not be, this chapter you will learn, may not be equal to number of protons. So in this statement, anybody having any doubt, please let me know. Do you all understand, everybody? I hope. So what I'm saying, in any atom, number of protons is always equals to number of electrons, but number of neutrons may or may not be equals to the number of protons. Do you all understand, everybody? Yes, please. All of you?
Yes, sir.
Yes. That is what. So now carbon is having atomic mass. What is the carbon atomic mass, everybody? Atomic mass of carbon. Atomic mass of carbon, I am saying that it is the 12 AMU. So 12 AMU means what is the number of what is the mass of one proton? Mass of one proton. We used to consider what? Don't know anybody. Mass of one proton is how much, guys? 1 AMU. Understanding? So now what is the number of protons in carbon? Number of protons in carbon, how many, guys? 6. So means in the sense of, due to the protons, what is the mass of carbon? 6 AMU. Then what about the remaining? Remaining 6 AMU is coming from where? It is because of whose that is? Mass of anybody? Mass of what?
neutron.
Mass of neutrons. That is what you have to remember it. I hope you all clear. Any doubt in this, please let me know. Understand, Amma? All of you? Any doubt, please let me know. Clear, guys?
Yes, sir.
Yeah. Make it. Mari, understand? Princey, Mr. Sam, Prithvi?
Yes, sir.
Yeah. Mr. Lingesh, rename yourself.
Yes, sir.
Any doubt, ask. Kavya, what happened? 2-3 days, not all there. Abhirami, any doubt, Abhirami? Sangamitrai, Arasani? Okay. So that is what you have to remember. So, discovery of neutrons only explained this. Extra 6 mass is 6 AMU is coming from where? That is what is explained by after discovery of neutrons only. So once again, I'm saying, remember. So why carbon is not having the atomic mass is 6? Because remaining 6 am is coming because of neutrons. So after discovery of neutrons only, it is explained that the extra mass of carbon is due to the neutrons. So six protons plus 6 neutrons is present. So totally 6 plus 6, which is equals to 12 AMU. That is what is the atomic mass of carbon. So any kind of atom like this only. So note it, everybody. Again, we'll study specially. So atomic mass means, remember, total mass of protons plus mass of what, everybody? Mass of neutrons. Okay, so that is what. So one proton mass we will consider mass of one proton, if you have been taken, everybody, 1 AMU, and same way one neutron is also is equals to 1 AMU. So that is why we will say mass of one proton is always equals to mass of one proton is always equals to mass of one neutron. That is what you have to remember. It is actually not exactly true. There is a small change, but approximately both are same. Is it okay, guys? Everyone? Yes, please.
Yes, sir.
So note it. So this is what. Sir, why was the neutron discovered later? That is our question now. So this is what is about the story of neutrons. Anyone having any doubt, please let me know. So now we are going to study about what makes the neutrons discovered later. That is what is the reason is. So as they are having no charge. So if you all remember that cathodic tube. Do you remember the cathodic tube, everyone? For discovery of cathode rays and anode rays, all of you? Yes, please. Speak, guys. Everybody. So you might be remember that if the cathode rays are passing, they are actually negatively charged and they are attracting towards to the magnet in a downward direction because they are negative charge. So they are showing some displacement. They are attracting by the magnet, displacing towards to the downwards. And if I take the cathode rays, positive charge. So if it is a positive charge, so if you are keeping the magnet, so they are displacing towards to upwards. They are displacing like that, they are bending. So that is what, because they are positive charge. So they are showing some displacement. But when Mr. J.J. Thomson, Mr. Goldstein, whenever they are conducting these experiments, as we know that the neutrons are present. Neutrons has no charge. So that is why they will never deflected in any electric field. They will never shows any deflectance with electric field. So that is the reason it has been actually we used to consider only electrons and protons are present in the atom and there is no neutrons. There is no discovery of neutrons by that time. So but later when hydrogen atom, if you have been considered all of you, so we all knows hydrogen specialty. Can you tell me what is the basic hydrogen specialty? What is the specialty of hydrogen? It has only what?
One proton.
One proton and one electron. So people used to consider only electrons and protons are there. But if you have been taken the helium atom, how many protons are there? Everybody. Helium atom, how many protons? Two electrons will be there. So two electrons. How many protons, guys? Two protons.
Two.
But mass is what? Mass is what? Mass is considered as 4U, 4 AMU or 4U. So it is 2 times of protons. So the mass of helium is 2 times of protons. Then only it is started thinking. They are started suspecting. Do you understand, everyone? So the mass of helium should be 2 times the mass of the hydrogen. But actually it is how many times? Everybody. The mass of helium must be 2 times if I have been taken. But helium how many times heavier than hydrogen? Hydrogen only 1U. Helium is 4U. So how many times it is greater? Helium is how many times greater than hydrogen, guys? Everyone.
Four.
4 times. Do you understanding? But if you consider only Only protons are there. Only protons are there. If consider only protons are there, helium must be how many times greater, everyone? Helium must be how many times greater? Helium must be 2 times greater. Is it right, guys? Because only 2 protons. Yes or no? But it is showing how many times greater? 4 times greater. Then it was suspected by Mr. Rutherford that there may be some other particle is present in the atom, but he not discovered. So please remember, everybody, it is first, the thought process is done by Mr. Rutherford only. So he noticed that atomic mass of the hydrogen is 1 AMU. So if you consider helium, 2 protons are there, it must be 2 AMU. But it is showing how many AMUs? How much mass? Helium, 4 AMU. So means helium is 4 times heavier than hydrogen. So how it will be possible? How could be it is possible? Then only Mr. Rutherford started suspecting some other fellow is inside, some other is inside is there, which is a neutral. So that is what after the discovery of neutrons by Mr. Chadwick, so it was confirmed that a nucleus contains not only protons. Mr. Rutherford said positive charge is located at where, guys? You all should tell. Mr. Rutherford said that positive charge is located at where? At the center of the atom. Am I right? Yes or no? At the center of the atom. Ma, nobody is answering, nobody is responding. Then why I should teach the class, ma? You all can take whatever you want. What is this, Mari? What are you people are doing? Sam and all. Simply attending. Lingesh. So, what Rutherford said, the positive charge of the atom is located at the center of the atom. And as we know, what is the size of the radius of the nucleus? Anybody can tell? How many times it is smaller? Any atom?
One,
1
1
time.
lakh times.
So 10 power 5 times it is smaller than the atom radius. So that's what Mr. Rutherford said. Majority portion of the atom is empty space. Only positive charge is located at the very deeper inside the atom. That is what he call it as something. What we used to call? What we used to call? Nucleus.
Nucleus.
Yes. So Mr. Chadwick, after discovering of neutrons, it has been confirmed that the nucleus contains not only protons. So it contains what? Both protons and as well as uncharged particles, which is called as a what? Which is called as a neutrons. So after that, protons and neutrons both is called it as nucleons. So write it as they are located in nucleus, they are called it as a nucleons. So nucleons means both you have to consider positive charge protons plus no charge neutrons. So it contains only one proton in its nucleus and one electron is revolving around the nucleus. Then it is hydrogen atom. But if it comes to the helium, they have been found that 2 protons are there and 2 neutrons are there, along with the 2 electrons are revolving around the nucleus. So that is what is about it. So they have discovered, Mr. Chadwick, by doing this experiment, he has been concluded that, so along with the proton, there is some other fellow is there in the nucleus. That is what is called it as an uncharged particle, which does not possess any charge, which we used to call it as neutron. So this is what he has been found it. Now, so after this, properties. So we should know, yes, how you can say the mass is 1 AMU. So then, that is what properties of neutrons. So please keep waiting, everybody. Properties of neutrons. So first point, neutrons does not have any charge. So what is that, everybody? Neutrons are no charge means what is that? They are neutral. They are not positive. They are not negative. So they are neutral subatomic particle. Neutral subatomic particles. And they do not carry what? Any charge is there or no? Everybody. Any charge is there or not, guys? No charge. They do not carry any electrical charge. They do not carry any electrical charge. That is what you have to remember. Next, the absolute mass of neutron. The absolute mass of neutron is approximately equals to proton. So if any one of you remember what is the mass of proton, I want to know. Let me see how many of you remember. What is the mass of proton? What is the mass of proton? Anybody? I already taught you and you should tell me also. Mass of proton. I told you to write the classworks and you have to show me. But nobody is doing. Mass of
1.6.
proton.
1 AMU.
1 AMU. That tell me in kilogram, Nivedan. Don't know. Oh, if you are not ready to work, don't join, please. I'm saying. What is the mass of proton in kilogram? Check your notebooks and tell me.
1.67 into 10 to the power minus 27.
1.67 into
10 to the power minus 27 kg.
same neutron also. So 1.67 into 10 power minus 24 grams or 1.67 into 10 power minus 27 kilograms. So that is why we will say mass of one proton is equals to mass of one neutron. Do you understand, everybody? All of you? Mass of proton is equals to mass of neutron. That is why in atomic mass, we'll consider the total mass of protons plus neutrons is equals to atomic mass of the atom. That is what you have to remember. So any doubt, anybody can ask. Clear, everybody? Yes, please. So that is
Yes, sir.
this.
Yes,
Write
sir.
it. Mr. Gokul Sangamitrai, this all you no need for me. The like this means 10th class and all no use. I'm saying you have to involve Mr. Kishore, Kavya. What is the use like this? Are you people or the kids need to request everything, So make it everything. So this is what is about the three subatomic particles. So now we are going to make the final conclusion about this one. So that is what is the electrons, what is the protons, and what is the neutrons. So keep reading now. So we are going to compare electrons, protons, and neutrons now, and finalizing the charges, everything. So first we are going to make parameters. So what is the parameters? Representation and all. So parameter. So about electrons, about the protons, and about the neutrons. Okay. So first parameter, notation. Notation means how to represent it. So notation, electrons. Electrons will represent it. What is the symbol? Electrons. Everybody. E minus. Protons. Protons how will represent? P plus or P. Your choice. Neutrons, how will represent? Today only I told. Small n. Okay, that is what. Next, location. Where they're located, everybody. Location. Electrons are located outside the nucleus or inside the nucleus, everybody. Outside the nucleus, inside the nucleus. Outside the nucleus. Protons. Protons. Inside the
Inside
nucleus.
nucleus.
Neutrons. Inside the nucleus. Okay, everybody. Next. Absolute charge. Absolute charge. What is the charge of one electron? You all should tell, I won't say. Charge of an electron. Charge of an electron. Charge. Unit of charge.
Minus
Coulomb.
1.6.
Yes.
Minus 1.6 into 10 power
Minus
minus 19 coulomb.
1.6. Only that girl is reading and writing. Reminding all the girls nothing doing. I know. Simply, Alfin, writing the classwork or not, say me. Otherwise, leave from the meeting. No problem. Minus 1.602 into 10 power minus 19 coulomb. What is the charge of proton? Plus 1.602 into
Yes.
10 power minus 19 coulomb. What is the charge of neutron? What is the charge of neutron? No charge.
Neutron.
Neutron. No charge neutron. That is what? Next. Relative charge. relative charge. Relative charge means +1 -1, that is what? So what is the electrons relative charge? Relative charge -1. Protons, what is the relative charge? Protons relative charge +1. And neutrons, what is the relative charge? No charge. So it is 0. Okay. So next one, absolute mass. What is the absolute mass, everybody? What is the absolute mass? Absolute mass of electron. Absolute mass of electron.
9.1 into 10 power minus 31 kg.
9.1 into 10 power minus 31 kg. What is the absolute mass of protons? Everybody.
1.67 into 10 power minus
1.673. Note it. I told you slight difference. 1.673 into 10 power minus 27 kg.
Yes, sir.
Next, neutrons 1.675. That is why approximately both are same we used to consider. Approximately. This is absolute mass. Now comparison. Comparison, we are going to do it. That is what is the sixth parameter? Relative mass. Relative mass, if have been done. So what is the relative mass? How many times electrons is smaller than hydrogen? Anybody? Hydrogen or proton? 1 by
1000
1
by
by
1000 into 10 to the power.
1857 times of whom? Times of proton. Or proton means
Protons.
what? Hydrogen. So because we all know
Nitrogen.
hydrogen contains what? Hydrogen contains only how many protons? Yes, please.
1 protons.
1 proton. So that is what? So proton mass is equals to hydrogen atom. Please note that. Mass of 1 proton is equals to mass of hydrogen. Nivedan clear? Mr. Lingesh, Kishore, Mari, Sanjay, what you are doing, I don't know. Prardhana also, Prardhana, Darshana and all, not ready to answer, not ready to respond, and active in the class, no need. You can just, please, I don't have any problem. So next, so what is that proton mass? Just now I said, mass of proton is equals to mass of hydrogen. So we can say is equal to whom? Equal to hydrogen atom. And as we know
Hydrogen.
that mass of proton is equals to mass of neutron. So mass of neutron also, what is that, everybody? Equal to hydrogen atom. Is it okay, everybody? Yes, please.
Yes, sir.
No charge will be greater, no charge will be lesser, Abhirami. In atom, always positive charge. Amount of positive charge equals to amount of negative charge. That's why atoms are electrically neutral. Understand?
Yes, sir.
Yes. So last one. This is very important, guys. That is what? Seventh point. So write it, everybody. E by M ratio. So note it, everyone. E by M ratio. Make it. So electron divided by mass ratios. Everybody, all of you do it. So how much it will come, you have to tell me. So E by M ratio. So write it. E by M ratio means mass of an electron. M means mass of an electron and E means magnitude of the charge. That is what you have to remember. Okay, everybody? So what is a charge of an electron? 1.6 into, 1.602 into 10 power minus 19 coulomb. And mass of an absolute mass is how much? 9.1 into 10 power 31. So you have to do it, everybody. So how much it will come? E by M ratios, you have to do it. So you can do it for charge, correct? Coulomb per gram, or you can do for coulomb per kilogram. That is what is the unit. So down you will do it and we will make it. So E by M ratio of first electron will do it. So electrons. So what will happen? E means charge, guys. So what is the charge? Anybody? Charge to mass ratios. You'll get it. So mass of what is that given? You all can notice it. What is the mass of one electron? Mass of one electron is how much? 9.1 into 10 power 31, and charge of an electron is 1.6. That's all. So you can do that and you can finish it. So charge of one electron is 1.602 into 10 power minus 19 divided by this one. Mass of electron is 9.1 into 10 power minus 31. So now you can see, everybody, 1.602 divided by 9.1. So 10 power minus 31 will go up. So what will happen, everybody? It will turn up into 10 power minus 19 into 10 power 31. Positive. Positive. So coulomb per grams. So do the division and tell me, everybody, how much it is fastly. 1.602 divided by 9.1. I'm giving time. You all should tell me the answer, then only I will say. Everybody do it. Don't use phone. Everyone, meeting is going to end. Join back and we'll continue. Answer, please. Nobody knows, 0.176 and 10 power minus 19 into 31. A power m into a power n, which is equals to a power m plus n. So 10 power minus 19 into 10 power 31, which is equals to 10 power minus 19 plus 31. So minus 19 plus 31, how much, guys?